And this example is like problem 6 in the exam 3 review. We have a dozen jumbo eggs that should weigh 30 ounces. The following table here are weights in ounces of a sample of 10 dozen jumbo eggs, and they're telling us it is reasonable to assume the population is approximately normal. So we have a random sample here, and we have an approximately normal population, so the requirements are met to do a confidence interval, and they want us to construct a 99% confidence interval for the mean weight round to 3 decimal places. We'll notice here that we're not given sigma here. We don't know sigma, so we have to use the t-distribution. So these are the formulas with the t-distribution. You're using s instead of sigma and t here instead of z. So n, our sample size, is 10. And then x bar and s we're going to get from one variable stats. So clear things out here. We want to go to the stat menu and edit. And we want to enter that data in. So that's 29.2 and 30.4 and 31.1, 29.7, 30.5, 29.9, 29.1, 30.3, 30.8, and 29.7. So then you want to go to Stat, Calc, and then one variable stats. Come down and calculate. So X bar 30.07 and standard deviation 0.6617. So 662 if we use 3 decimal places. So 30.07 for our mean, and standard deviation 0.662. 99% confidence means our alpha is 0.01, so alpha over 2 would be 0.005. So our t alpha over 2, our critical value here, we're going to use inverse t to get that. You have to put in the left area. 1 minus, remember 0.005 is the right area. This little subscripted number here, that's the right area. So 1 minus 0.005 is 0.995. And we're going to put that into inverse t. And we also need our degrees of freedom, which are 10 minus 1, 9. Go ahead and compute that. So go to the distribution menu, second variables. We want inverse t, number 4. Area, 0.995. Degrees of freedom, 9. Paste it. Enter. 3.2498, so 3.250. So now we can go ahead and plug in. So our x bar is 30.07. We subtract the 3.25 times s, which was 0.662. And that is going to 662 be divided by square root of 10 minus 1, 9. And then we do the same thing, but adding the margin of error. So 30.07 plus the 3.25 times 0.662 over root 9. So let's go ahead and compute our margin of error there. So we've got 3.25 times 0.662 divided by square root of 9 is 3. So 0.717 to 3 decimal places. So 30.07 minus 0.717, and then 30.07 plus 0.717. And if you subtract that on the calculator, you'll get 29.353. And if you do this addition on the calculator, you will get 30.787. So there's our confidence interval, 99% confidence interval. And we can check this using t-interval on the calculator. So you want to go to stat, tests, and then we want t-interval, number 8. We're going to use the actual data. So highlight data and press enter. And we are using list 1. We put it in list 1. Our confidence level should be 0.99. And then we will calculate. So 29.39 to 30.75 right here. And we've got 29.35 to 30.78. So these are differing slightly. And that difference is just in the rounding of the sample standard deviation S. We round it to 3 decimal places, and that's what's throwing things off here in the second decimal place. So these really do agree with each other. This is the more accurate answer using t-interval. So now part B, the quality control manager is concerned that the mean weight is actually less than 29 ounces. Based on our confidence interval, should the manager be concerned? Well, our confidence interval goes from 29.35 to 29.79. So we've got that 29.35 up to 30.79, and 29 would be down here. And that's not in the interval. And 99% of samples will contain the population mean, so 29 is probably not the population mean. There's only 1% chance that's the population mean. So no, should not be concerned because you're 99% here of your confidence intervals should contain the population mean mu, and 29 is not in the interval. So they want us to fill in the blank. Quality control manager should not be concerned that the mean weight is actually less than 29 ounces. So, and again, because it's outside the interval, that only happens 1% of the time.